Today we're going to be working on growing more. So we have 2 pages here, and each page has a different series of dots, and then there are questions that follow that. The first question says, describe and annotate the pattern of change you see in the above sequence of figures. So we start with 2 dots here, and something happens, and then we get this shape. And then something happens, and we get this shape. And it should be the same something every time. And then something happens, and we get this shape. And then this one. And using that same pattern, we should be able to predict what the next shape is. So number 1 asks you, figure out what's happening. What is the pattern in the picture? Number 2 says, assume the sequence continues in the same way. Fill out the chart up to 5 seconds. So the first one is going to be 0 seconds. There are 2 dots. 1 second, there will be 3 dots, and so on. Going on down, 2, 3, 4, and 5. 4 you can count. This is 4 seconds. But 5, you either have to identify the pattern in the dots, or you look at the chart and determine what the pattern in the chart is, and then you fill out how many dots there are going to be that way. Once you figure that out, question 3 says, write an explicit formula to describe how many dots there will be after t seconds. And if you don't like t, you can change that to x. That's no big deal. So is this linear? Is it quadratic? Is it exponential? Whatever it is, you should be able to see that pattern in here. And then you can use your calculator, go into Stat, Edit, put in however many points you need to put in, and then you can figure out the equation, whether it's linear, exponential, or quadratic. So in just a second, we're going to pause the video so you can work on questions 1, 2, and 3. But as soon as you finish 1, 2, and 3, you'll flip over to the back side. You'll do the exact same thing for questions 6, 7, and 8. It's just a different pattern of dots, but it's the exact same questions. So right now, we're going to give you time. We'll pause the video, do questions 1, 2, and 3, turn it over, do questions 6, 7, and 8. It might take you 10 or 20 minutes, whatever it takes. We'll restart the video, and then we'll go through the rest of those together. So go ahead and pause it right now. Okay, welcome back. So for this chart, we should have 0, 1, 2, 3, 4, 5, 6. And we start with 2 dots, and then we have 3 dots. And then we bump up to 6 dots. And then 11. And then 18. Excuse me. So the pattern for the first difference is +1, +3, +5, +7. And the second differences are +2, +2, +2, which means the end of the list of first differences should be +9, which means there should be 27 dots. And there are a couple different ways to see patterns in here. Most people see a base of 2 dots, and then we sort of just put a hat on top of those 2 dots. So here is the hat for the first one. There's the hat for the second one. And then there's a hat. And then there's a hat. So the next one would be this same picture here, but you would have an additional hat on top of that. And if you count up those dots, if I do it right, 1, 2, 3, 4, 5, 6, 7, 8, 9, that should match this. So that at 5, there should be 27. And you can see that both in the table of values and in the picture. We know that this is quadratic. It's some form of x squared. To figure out what the equation is, we need 3 points. So any 3 points will do. So I'll turn on my calculator, go into Stat, and then Edit. And I want 0, 1, and 2. And then the y values associated with that would be 2, 3, and 6. Okay, so that chart should match this chart. And then I push Stat again and go over to Calc. And this is quadratic, so that's number 5. Go down to Calculate. And it says the formula is 1x squared, so x squared, plus 0x plus 2. So I don't need to write 0x. The explicit formula is x squared plus 2. And I think it's usually good once you have an equation to match it to the dots itself. And you might look at this and say, do you see x squared plus 2? An x squared for each of those x values would be a 1 by 1 square, a 2 by 2 square, and a 3 by 3 square, and so on. So for each of those pictures, you should see a 1 by 1, a 2 by 2, a 3 by 3, and you see 1 by 1 plus the original 2 dots there, but this one doesn't quite look like a 2 by 2 unless you move this dot up here, and then you see 2 by 2 plus 2. And the same thing can be done in every other picture. If I move those 3 dots up here, they fill in the square perfectly. And we're left with a 3 by 3 square, so these are gone, plus 2 dots. And if I get rid of those and put them here, now I have a 4 by 4 square plus 2 dots. And maybe you see a different pattern, but that one's pretty common. Let's look now at number 4. How many dots will there be in 18 seconds? Well, the equation is x squared plus 18, or sorry, that's not what it is. It's x squared plus 2. I want to know what is the answer when x equals 18. So I plug 18 in there. 18 squared plus 2. So in my calculator, 18 squared plus 2. 18 squared plus 2 is 326. So in 18 seconds, there will be 326 dots. So the answer to number 4 is 326. How long will it take to reach 627? There are a couple ways to do this. We could just keep trying numbers. Say 24. So 24 squared plus 2. That's not enough, so maybe 30. 30 squared plus 2. 902, that's too much. Maybe 26. Oh, not 36, 26. 678. Still too big. 25 squared plus 2. And that gives me 627. So the answer is 25. But I don't want to do that every time. I don't want to guess. I don't like guessing. So a better way to do it is to go into y equals, into your graph, type in the function, x to the second plus 2, and we could look at the graph and try to figure it out that way, but there's an easier way. Above the graph button, so the graph button is on the very top right, there's a little blue word that says table. If you push second and then push the graph button, now we have an XY table. And if we scroll down, we just keep going until we find 627. And it will take us right where we want to go, right there. Maybe I've gone too far. Come back. Come back. So 25, 627. Right? Maybe I can make that a little bit bigger for you. So when x is 25, y is 627. So that's a good way to find y values in the future. Or if you're looking for some sort of range, you can type the function in and then just use your calculator to find what you're looking for. All right. So on the back side, the table of values should look like this. We start at 1, 2, 3, and 4. In the first picture, there's only one dot. In the second picture, there are 7. And then in the next picture, we take that original 7, and it's sort of the same pattern. We're going to add another 10, so 17. And then in the next picture, we're adding 14 more dots, so that would be 31. As far as first differences go, plus 6, plus 10, plus 14, it's not linear. Second differences, plus 4, plus 4, this is a quadratic equation because the second differences are constant. So for number 6, you need to annotate the pattern, whatever pattern you see, and maybe you see a different one. You need to describe it or circle it and describe it. Number 7, assume the sequence continues in the same way. Fill out the charts to 6 minutes. So if the second differences are always plus 4, then 14 added to 4 is going to give me a first difference of 18, which means at 5 minutes, 18 and 31 is 49. And 18 and 4 make us a first difference of 22. So at 6 minutes, 49 and 22 is going to be 71. So there should be 71 dots at 6 minutes. Okay. As far as the formula goes, we know it's quadratic. And we know that the second differences are 4, which means the equation is going to be 2x squared, something else. So if I go into my stat, make this big so you can see it. Go into stat again, go over or into edit. Same x values, 0, 1, and 2, but my y values have changed. They're now 1, 7, and 17. So 1, 7, and 17. And then go back into stat, go to calc. This is a quadratic, so number 5. Go down to calculate. 2x squared plus 4x plus 1. So my equation is 2x squared plus 4x plus 1. Number 9 asks, how many dots will there be in 13 minutes? Well, I just plugged 13 in there and in there. So 2 times 13 squared plus 4 times 13, and then plus 1. That gives me 391. The next question wants to know, how long will it take to reach 1681? Well, once again, I would rather have the calculator do the work. So I'm going to clear out, I'm going to go into y equals, which is the very top button, top left. Plug in the formula, 2x squared plus 4x plus 1, and then second graph, second table. And this table should match the table that I had originally. So you see there's the 49 and the 71. Oh boy. Maybe. This is a little overeager. So there's the 49 and the 71 that I calculated by hand. In fact, here's the 13 that I calculated, the 391. And I just want to keep going until we reach 1351, which is 25. So how long will it take? Oh, sorry, 1681. So 1681 is 28 seconds, or minutes. So the answer is 28 minutes. The last thing we need to do today is very similar to what the assignment was yesterday. Find the equation for each of the quadratic functions below. So you already know all of these are quadratics. All you need to do is pick 3 points, plug them into your stat, do a quadratic regression, and write the equation. Oh, they're not all quadratics. I lied to you. For each equation, find the equation for each of the quadratics. That needs to be fixed. So you don't trust that. Figure out if it's linear, exponential, or quadratic. Once you know what it is, plug in the numbers and find the equation. So for number 14, you'll have to pick some points. So that point right there is -1, 10. And find some more points. It looks like right here is -4, 1. And then we also have 2, 1. So your table of values would be -1, -4, and 2. And your y values will be 10, 1, and 1. And you'll plug those in and do a quadratic regression. On number 15, it's obviously not quadratic, it's linear. So pick some points and do linear. On 16, you need to figure out what sort of pattern it is. So for number 16, looks like the first point is 0, 1. And the next point looks like the next point is 1, 3. And the next point is 2, 9. And then 3, 27. And the pattern here is times 3, times 3, times 3. So this is exponential. To find that equation, you plug in 2 points into your stat, go into exponential regressions, and calculate, and that will tell you the equation. Okay, when you get this done, hand it in. Good luck.